My whole life, I've lived on a farm. I've worked with farm equipment and working with animals, and many times different things fail, and you look at how different things are made. So intern as a machinist. My name is Williamson. I'm 16 years of age. I've been in 4-H for 14 years, ever since I was a kid, really a toddler. Before I was at Clover, but really working with my brothers and sisters in 4-H, mainly animal projects. But I interned the machinist because I was really interested in how different objects were made, how mainly metal, but also wood. And I worked with two different types of machines for that. I worked with the mill and the lathe with my expert Greg Hanley, who is a part-time machinist and also a part-time horse trainer. So he does not do this full-time, but has had training in this and knows what he's talking about. So the two different machines I worked with, the one in the picture here is the lathe, which works with cutting circles. So the tool is pushed into the object, and like the shaft of this bolt is a circle. And the mill, instead of spinning the workpiece and holding the tool, the mill spins the tool and holds the workpiece so you can machine the flats on this nut, which I also made, which is getting into how I made this. So the first thing I need to do is develop it, which is development and design. I follow designs for a 1-inch heavy-duty aluminum nut and bolt. There's a machinist handbook in which you follow designs, and it has the thread pitch, which is you go in the transmission, the lathe, and adjust the speed. And you follow all the designs to the thousandths of an inch. This is smaller than a human hair of precision, and adjust those as needed. Next thing I need to do is create it, of course. So I follow the dimensions. I mounted the aluminum. In the mount, it applies pressure but doesn't crush the aluminum or whatever material you're using. And I follow those dimensions, learning how the machine works. And that was probably one of the most difficult parts for me. So that gets into the difficulty of this project, which was I had to grasp the concept of working this machine that was 10 times my weight, 10 million times my strength. And if I was wearing loose clothing like ties, safety glasses were required, I could get sucked into the machine, lose a limb, lose a life, my own life, if not done properly. These machines were manual, so there was no computer control. So when I spin a dial to move the tool in or out, I was the one mechanically doing it with gears, moving those tools around. A lot of machines called CNC machines, computer controlled, they will automatically move it. Since I'm moving this dial, you can feel the gears turn, and such as you can feel when even if the dial moves, the gears, you may not feel them move. So that's play. And you really have to get a good feel for those gears. And that's why people go to trade school to be a machinist. Because it just takes that feel so you can feel the machine working, not just looking at your eyes and saying, oh, I've rotated a quarter of an inch. That should be 10,000ths of an inch. And not really. You really have to feel that. I was taking in instructions from Greg and putting them into use on the physical piece right here, which is hard. This is something that it needs to be done safely, and I'm trying to learn it on the fly as soon as he's telling me how to do things, but I was able to do that. I couldn't drive myself to his shop, so I had to work with my parents to get there and get back, do everything, and like I said, he's not full-time machinist, so we had to balance our work schedules and get everything worked out. It gave me a lot of life experience on sometimes things are out of your control. You know, you can't just say, meet this time, please, and things just can't work out like that. So, in retrospect, I've learned a lot about what a machinist does. Personally, I want to be a mechanical engineer, and a machinist wouldn't be that bad of a job. I spent a lot of time on this with the tooling, surface finishes, slowing down so you can get the precise finish and all the tooling for this. And there's a lot more that goes on behind the scenes once I, in theory, design a part as a mechanical engineer that I would never see without interning with Greg and learning how to make things like this. Why did I choose a nut and bolt? Mainly because it's a complex object that many people don't even realize. It has internal and external threads, multiple tools, and I just wanted something well-rounded to give me all the experience that I would need to, know what goes on for these impossible parts that I may design too. I can't create a perfect circle with my hands. It's impossible. You need a computer to perfectly make an angle. And if I try to make something specified to 45.325 degrees, there's no way you're going to be able to measure that and cut it accurately on a hand mill and lathe. So it really gave me that experience. Without that, I would be lacking in a field, even if I went to college. Having a hands-on experience is something you don't get. So thank you, judges, for your time. I have the part up here. Of course, you're not here, but you could, in theory, see it with your own hands or eyes. Thank you for your time. Any questions?
And for some questions, how do you think 4-H has impacted you getting involved with this?
Like I said, I live in a farm. I've lived in a farm my entire life. I've seen heavy machinery from tractors to fences and T-posts and machines producing all these different items. And I really was just puzzled as a kid how, as a society, we've developed these things from rocks from the ground to giant hydraulic pistons moving thousands of tons of material around. And 4-H, growing up on a farm, of course with 4-H and working with farm animals mostly, kind of transitioned me into a mechanical type of field that I'm interested in. Maybe working with agricultural equipment, tractors, different things like that.
Cool. So do you think this is something that you could implement with 4-H, or is it a little too dangerous for most youth to do?
It's a good question. I think if it's done properly, it can be done safely. I would say CNC or computer-controlled machining is arguably safer than manual, which is what I did, because there's a lot more. You're pressing a big red button and you can stand far away from the machine and let it do its own thing. And most of the time that has armor shielding around it, and you slide across a bulletproof glass, and this was all open. You could stick your finger in there and get it chopped off. But I would think if this was to be implemented, arguably a CNC or computer-controlled mill and lathe would be better, but I definitely think it can be done. I would say ages 8 and up could probably do it.
All right, thank you.